close this down and let's toggle over here. Excellent. So as I promised last lecture, today's lecture we would pick back up with the traditional presentations, really doing a deep dive into all the characteristics and attributes and properties of JavaScript. So up until this point, we talked about JavaScript basics, and we've done 2 lectures on all the JavaScript applied data structure content that's built into the language. So here, I really want to highlight all the object-oriented JavaScript principles that are provided to us. And then once we're done with this lecture, we can start examining how we can use JavaScript specifically in the browser to start accessing the document object model. So that'll be for the next lecture for next week. So for this lecture, let's talk about, why don't we examine what the goals will be. So we'll do a quick breakdown of OO.js as an examination of what are objects in JavaScript, what are classes and how do they compare to objects, what does it mean to have class-based inheritance in JavaScript, which, believe it or not, is a relatively new addition to the language. The older inheritance model was one that was called a prototypical inheritance, and I'll just briefly mention that and kind of give you the idea of how it would work. But we're going to really use the newer refactored class-based inheritance that's much more Java-like and what we're much more used to. We'll take a look at using the spread operator and destructuring on objects and how that might be useful to us. And then we'll take a look at some of the object methods, so the static methods defined in the objects class, similar to how they had some very powerful processing methods for arrays in the array class. It's a similar deal with the object class. Okay, so with that said, let's take a look at objects themselves. So we'll break objects down into a couple different subsections. We'll explain what an object is in terms of JavaScript. Then we'll look at how to create objects. We'll explain how to add properties, which are essentially key value pairs to an object. We'll talk about how we can access those properties. We'll talk about how we can remove those properties. And then we'll talk about how objects actually exist as a data type. Hint, hint, they're not a primitive data type, and what implications this has for us. Okay, so objects. Object is essentially a collection of related properties and behaviors. So you have a property, it has a data value, and you have a behavior that is a method. So objects are very much conceptually what you think of as the instances that you build from classes in Java. However, objects, as opposed to instances, in this case, aren't necessarily derived from a class. In fact, an object is more like a container of things that come in key value pairs. So for that reason, we can think of objects in JavaScript as the same thing as a dictionary is as a data structure. And so for those of you who might have programmed in Python before, an object in JavaScript is very much a dictionary in Python. So since we can describe objects as dictionaries, the reason why we can do that is because recall that functions are also object data types in JavaScript, which means that we can assign a function as a value to a name. And so that is what allows us to have named data values and named methods within a container class that very much looks like a dictionary. And of course, as you might all recall from Java 1, we use objects for data modeling. It's a paradigm by which we can architect our software. We think of objects as these very useful things that can represent an entity in our software system. So why might we want to use an object as opposed to a class? Because we know that classes are and instances are used in JavaScript. Well, objects are quicker and easier to define and use for when you need a single instance of a thing. So if you're not building very many of these instances, then just create an object. No use having to go through all the headache of creating a class for effectively a singleton. And so we want to think of objects as the most abstract container of properties. Once it's created, it can actually model any one thing we need it to be. So with that said, how can it model any one thing? Well, objects are incredibly mutable. The mutability of objects, so object properties, so we can start just like an array in JavaScript is incredibly mutable. You can start with an empty array. You can initialize it to have some set of values. You can remove elements. You can add elements. Objects, we can do the same thing. We can add elements at any time. We can delete properties, or I'm sorry, we can add properties at any time. The things inside, the thing contained in an object is a property. The thing contained inside of an array is an element. So let me not get this confused. So we can add or remove properties whenever we wish. And so a object may start empty, or it may start with a collection of key value pairs that we define inside of it. So let's talk about how we might create just objects as they exist without the consideration of classes and instances. Well, there are three ways that we can generate just a basic object. We can use the object initializer, which is also referred to as the literal notation. We could use the object constructor method, or we can define a factory method. So let's examine how those actually look. The object initializer, I think we've already seen before. Super simple. We use the set of curly braces and assign that to a variable. And if we do that, we've just defined an empty object. If we want to have properties contained within that object, we can go ahead and specify them as a key : value pair. So here's an example that I did right inside of the dev tools, right inside of the interpreter, the console. I have key 1, : and then a value, and a key 2, : and then a second value. Notice the keys can be defined as a variable name, so I don't necessarily have to cast them into any particular type of data. Whereas the values have to be represented as some type of data. So I couldn't just type in val1 here, because that would try to dereference a variable that doesn't exist. However, for the key, is actually creating a variable with that label inside this object. So do know that there's a little bit of a nuance in the rule between defining a key and defining a value when using literal notation. And then the result of this would be a object that has two properties, a key 1 and a key 2. Okay, let's talk about how we can create objects using the object constructor. Super simple. Right here, I just use the new keyword, same as I would in Java, and then invoke the constructor on object, which just happens to be the class name object, just like in Java. And to invoke a constructor, to invoke any method, you always use the parentheses, right? Now, unlike in Java, we can actually pass a function object around our software system, in which case we're not invoking it, but we're actually providing that function to somewhere else in our system. This isn't what we're doing here, though. Here we're actually invoking the constructor to instantiate an instance of just object, which is going to be empty. And there's really nothing you can pass in. There's no easy way you can pass anything in the parameters to provide value. So if you do use the constructor, you would have to mutably add in your keys afterwards. And I can show you how to do that in just a moment when we get to that section. And then the third way we can create objects is a way that I think we should definitely talk about. It uses a factory pattern. So this is probably something you talked about in Java 2, a factory pattern. So in this case, it's a factory function. So it's a function that would be designed to take in usually some set of parameters, but not necessary if you already know how it's going to be configured. And it returns back a configured object for you. So instead of the user having to define all the keys and values, the function takes care of that. So what's the use case for a factory function as opposed to using the constructor or using the literal notation? Well, the literal notation is good for when you need a single object, but these factory functions could be great if you need many objects and you don't necessarily want to go through the rigmarole of creating a class to do that, although it's not that difficult. So factory functions offer the ability to easily produce object instances without diving into the complexity of classes. So if you only need a couple instances, or if it's only like attributes that you're adding and that's it, this isn't a bad way, because you could do this in one line of code. And I'll show you how to do that. Let me see what the comments are here. Make sure I'm not missing questions. Okay, so here's some examples of what a factory function actually looks like. And so let's start right over here with a function declaration. So if you recall from our discussion in JavaScript basics, there's actually 3 different ways we can define functions. We could define function declarations, we could define function expressions, or we could do fat arrow functions, which is the functional programming paradigm way that we typically can chain or cascade our function calls. So with function declaration, that's where we use the keyword function, we give it some type of name, and then we give it a body. And so what happens here is you have what's called function hoisting, which means that this gets hoisted to the top of our code base as soon as the interpreter reads this function. And so that's the big distinction between a function declaration and a function expression, is since the expression is a variable that's being initialized, it doesn't get hoisted. So only declared variables, uninitialized variables that are vars and functions get hoisted to the top of our interpreter. Everything else will remain where it appears in the code base. Anyway, so this is a function declaration. And so if I were to declare this to illustrate what would happen, I then invoke it. So I call this foo. I'm going to pass foo 5, 10 as the xy values. And notice it's going to return back to me a object with a property x, which has a value of 5, and a property of y, which has the value of 10. Now notice what's happening here is it's using x and y, right, as the names for those properties, and then the x and y on the right hand side of this colon are actually being dereferenced from this factory function. Okay, perfect. So let's look at function expression. It's exactly the same, only we're assigning our function object to a variable instead of just doing a function declaration. So that's the beautiful thing about functions existing as objects in JavaScript, is we can actually just assign them and store them as variables and pass them around as need be. And so here we can invoke it the same way, it returns the same thing. So these are pretty much 2 sides of the same coin. Let's see how we might define a factory function to create an object using the fat arrow function. So here I will create foo, and I will assign it a fat arrow function, so an x and y. And here you'll see I'm using the literal object notation to, just like I did in the previous cases, here, here, and here, to define this object that's going to get returned. However, notice I'm wrapping the object in parentheses. And so that's a big deal. But this is why sometimes it's nice to have factory functions. If it's something that's relatively simple, like something to produce points, and you don't care if it's public, it's just a container to contain an x and y attributes. Maybe I should have called this point. Then in one line of code, I have something that I can constantly invoke and get new point objects that have whatever specified value is. I can even define default parameters in there. I think that's my next slide. That will even initialize it to 0. So why do we have to use parentheses to encapsulate our object literal in our fat arrow function? Well, it's because of the way that JavaScript does the parsing of the code. So keep in mind that curly braces are actually used to signal one of 2 things to the JavaScript interpreter. Either it's the start and end of a code block, or it's the start and end of a object, a literal object. So without context, it will always preference to treat it as a code block. And in fact, that's how we would create multi-statement blocks of code inside of a fat arrow function. If your fat arrow function has more than one statement, you have to encapsulate it in a code block, which uses the curly braces. So if we want to instead tell the JavaScript interpreter, no, don't treat this as a code block, treat this as a literal object notation, then we first wrap it around parentheses, because a code block can't exist in parentheses. So immediately it gives enough context to the interpreter to know to treat those curly braces as a literal object definition instead. So that's just one thing to be mindful of if you are going to create a factory function to produce objects inside a fat arrow function to use these parentheses. And if you don't, this is what's going to result. If you just try to do the parentheses themselves, it's going to say unexpected token, a colon, because it thinks what you're trying to do here is define a block of code. Okay, and so like I was saying earlier, you can also define parameters, default parameters or default values inside of your parameter list as such, so that if we invoke this function with no parameters, it'll go ahead and actually give a definition to X and Y as 0, which is what the defaults are. And you can do that with any function. It's very powerful. That's what we have instead of method overloading inside of JavaScript. We have the ability to provide default values. Okay, so now let's talk about how we can add properties. Remember, properties are added as a key value pair. And so one reason I wanted to highlight the fact that in JavaScript, objects can be considered object-like entities and dictionary-styled entities is because we can actually use both types of notation to add properties, to delete properties, and to access properties. So for those of you who are familiar with dictionaries, well, whether in Python or like maps in Java or hash maps, you use bracket notation. So the bracket notation is essentially indexing into a keyed collection, just like with an array, you index into an indexed collection, which is just a integer number as your key. So we can use this dictionary-styled access method where we use the brackets and we pass in our key. And so the nice thing actually about the bracket notation for accessing items in your objects is that you can actually pass in any type of data in there. Whereas with dot notation, which is the more object approach of accessing data. So here, notice I create a new object. I'm going to add a property where, okay, in the brackets, I'm going to put the number 1, and then I'm going to assign the value of 1. So key value pair. I'm going to do the same thing with foo. So I'm going to use a number as a key. I'm going to use a string as a key. And here I'm going to assign the value of bar. When I inspect my object, it shows I have a key of 1 to the string of 1 and a key of foo to the string of bar. So in dot notation, notice I could do a new object. I could use a normal label, so I have to use the same rules that apply for variable naming. So foo is the valid name, and then I'll assign bar. I inspect, yeah, that worked. But guess what? You can't normally name variables starting with a number. That's against the rules. And so if I try to use the dot notation and assign the number 1 there, notice, bam, I fail. However, I can do that with bracket notation. So this gives you a very fluid way. Sometimes there might be reasons you want to use the bracket notation over the dot notation because of the flexibility of this. So where this is the more traditional way, you normally access values for properties in an object. But just note, both those are available to you for adding properties. So let's talk about what are legal values that a property can have. So they're all tied to names, but we can either do data values or we can even declare a function. And so now if I inspect what is the result of this, I see I do have a num property that has the value of 10, and I have a foo property that has the value of a function. And I can actually go ahead and invoke that function. I can pass that function. I can access that function any way I wish from inside my object. Also, something that's worth mentioning when adding properties is the ability to do composition with objects or essentially nested objects. And we can even use literal notation for that, object literal notation. So here, I can initialize an object. I use an object initializer on OBJ, and it'll be assigned this open closed object. And inside here, I'll add a key called nested. And the value of that key will be another literal object where it has a key and a value. And so when I go and execute this, it will create a nested object where I have a key nested and an object as the reference. And if I unpack that, I can see that that inner object has a key foo and a value of bar. Okay, so let's talk about how we can access the properties once we've added it. Well, again, we can use bracket notation the same way we would for a array or a dictionary or a hash map or map. And so here, if I had a object and I'm going to initialize it with some values, if I go ahead and dereference the value of x, and notice here though, I actually have to pass the x in as a string if I'm using bracket notation. It just have to resolve down into a value. If I try to just pass in x, it'll look for a variable declared x and try to dereference that, and that doesn't exist. So I will pass in the name of the key that I'm looking to access based off of the string representation, and so I can dereference that 5, or I can pass in that number, right, like I did before, and get back 10. And then I have my dot notation, so I could do the same thing. Right, well, kind of the same thing. I can create this key of x and a key of 10 with dot notation. As we already mentioned, we can access the x, but we would not be able to access that 10 with the dot notation because that is not a valid identifier. It's not a valid label for a variable, and we're constrained to dot notation to follow those rules. We're not with bracket notation. Okay, so let's also talk about this an in operator. So that's another way we can access properties potentially. It allows us to get a Boolean result on whether a key is in an object or not. So say I create this object that has the keys x and y. I can then say, well, is x in my object? And it will say true. And if I put like z is in the object, it would say false. Okay. Things to be aware of when accessing properties of an object. Remember, in JavaScript, one of the more powerful things, the idea that functions are objects, can also be a dangerous nuance. So understand that invoking a function versus just returning the function or accessing the function are two different things. So let's look at, you will use these things in different ways as you develop JavaScript code. So it's important to understand the distinction with them. So suppose I have this object that has a key of foo, and in this key, I just created a function. I just used a fat arrow function. So given an x, I will return x to the power of 2, so x squared. And so now I will access from my object the value at just foo. That is accessing the function object. And notice what's returned in the console is the function itself. If I wanted to actually use the function, I would use the parentheses and pass a parameter into it. So in JavaScript, when you see that a function object is being dereferenced, if it doesn't have parentheses, it's being dereferenced as a function object, as an object that contains a function, versus when you use the parentheses, you're actually calling that function to do work. So in this instance, I'm actually returning back the result of that function. So just keep in mind that those are the two ways that functions can be dereferenced in general in JavaScript, whether it's contained within an object or whether it's like a global function or whatever. Okay, what was this other exceptional? Oh, exceptional behavior you should be aware of is that you can access non-existing properties in JavaScript, just like you can kind of put in whatever index value you want in an array. So if you ask JavaScript, so let's say we create an empty object and then we say, hey, what's the value of the object at key X? Well, it's going to say, well, there's an undefined object there because you never defined something. But it doesn't produce an error. So this is one of those things that if you're unaware of, can produce a silent failure in your code. You might be doing a lookup on something that isn't an object, and it does execute that without reporting the failure. So do keep in mind with that. And so if something happens erroneous in your code base, you would console log for these kinds of things. Okay, let's talk about how we can remove properties from our object. So suppose I had this object with a X and Y key. X is 5 and Y is 10. right? So that goes ahead, executes fine. There's actually this delete operator we can use to remove properties from an object. So, and I could actually use this. I should have showed this. I could actually use the delete operator either with dot notation or bracket notation. So I could say, okay, from my object at dot x, that key, delete that. And so it's going to return back a true or false response on whether it's successfully deleted it. In this case, that key did exist, so the deletion was successful. So if I inspect the object now, it is now just y:10. It is lacking that x attribute. And again, I could delete that using bracket notation as well. And I could attempt to delete something that doesn't exist, and then it would return a false value, and it would look the same. I could also remove properties using the spread operator and destructuring, like we talked about in data structures, the data structures lecture. So given this object, as we've defined it before, I can destructure the contents of that object. So remember, in curly braces, I can put my variable declaration in curly braces. And so the trick here with objects is that you have to use as your variable name the same thing the key name is. So since I have a key of X and a key of Y, I could do a destructuring of just the X, comma, and then I could do the spread operator to get everything else. And so what this would effectively do is it would give me an X value that actually has the value of 5, but then this rest is actually an object itself. So this would be a primitive value of 5. It would not be an object that returns out of here. It would just be a variable of X. But the rest keeps the object encapsulated. So if I needed a means of removing the X from this object, this is an alternate means as compared to the delete. So spread operators, destructuring, super powerful and super worth knowing. Okay, let's talk about what it means for objects to be a reference type. And so this is true for instances of classes too. Objects are reference data type. An object passed into a function can be mutated for all other references within the app. And so be aware, if you give an instance of an object to a function, if a function mutates it, it will be mutated for everything else. Example of that, let's create an object here that we'll call bar. It just has a key value pair of X and val. We'll console log bar. We see, yep, that's what it has. Okay, let's create this fat arrow function called foo that, given some object, it will set the X property of object to 0. So I'm going to pass our bar object into foo and then console log out the value of bar, and you see that it did go ahead and update the actual state of that. So just keep in mind that objects get passed around as reference types, just like arrays do. So any mutations to the object will be reflected to everything else that has an instance to it. And that actually is taken advantage in the lab that you have. That's how a controller object can have a reference to a player instance and control it around, while the scene is drawing it in all the new places. We're taking advantage of the fact that it's a shared reference between those two other instances. Okay, so one thing you might want to know then, since this is a reference type, a very common problem is, well, what if I don't want to change the attributes of an object? What if I want to create a copy of it so that I can mutate my copy while saving the original state of the original? And so what you're really going to have available to you in pure JavaScript and basic JavaScript is the ability to easily create shallow copies. You do not have an easy mechanism for deep cloning or deep copies without using an external library. And just to specify the distinction between a deep clone and a shallow copy doesn't work for any kind of nested reference types. So it's great for copying things that have primitive data, but the moment that one of your attributes, one of your properties inside the object is itself a reference type, you won't be a copy. It'll actually that will be a shared attribute between your two copies. And I'll give an example of this. Imagine if we had this object that had the key R that actually had a reference type of an array and has a value. It's initialized with a value of 100 in there. And so let's also have another key in here, number, that has the value of 100. That's a primitive data type. We will use the assign So there's two ways we can go ahead and make a copy. We can use inside of object as a static method, and we're going to look back at this at the end of this lecture. Is an assign. We will assign the contents of object into an empty new object. So it takes this left-hand thing and puts it into the right-hand thing, and then returns it out as this copy. And so now when I do that, I get this copy, right, with an array and a number. And so unfortunately, if I go into my copy, access the array, and try to re-index into it 0, and then I console log those two things out, notice my array has been updated in both my original and in my copy. So yeah, reference types does not work. Shallow copy only. It's not. That's what it means to be a shallow copy. However, if I change the primitive data type of number, I see that right here, object.number is preserved inside my array. So easy way. So you could either use this or the spread operator. I prefer to use the spread operator when making shallow copies because it's stupid simple. So here's the same object. I'll make a copy by just essentially destructuring it and returning the rest of it as copy. So remember, that maintains it as a object, but it produces a new object from what's being spread out. And so my copy has those two attributes, but it's a shallow copy, just like what assign does. So if I have something like a array and I index in and change a value in there, it gets changed in both my copy and my original. So just things to be aware of. Something you should definitely know when working with objects is that even if you produce a copy, to expect that your copies are going to be shallow. And there are solutions for making deep clones, but that is beyond the scope of this lecture. I'll leave that to you. Okay, let's talk about classes now. So in classes, we'll talk about what does it mean to be a class in JavaScript. We'll talk about the class keyword. We'll talk about how we can declare instance variables, or what are instance variables in JavaScript, what's the constructor method, what are instance methods, the this keyword and the rules for scoping around it, and the static keyword. So pretty much everything that you learned how to use in Java for the most part, we'll take a quick look at here. So, well, classes serve as a blueprint to construct many different instances. You can instantiate a class into an instance with its constructor. Classes can have properties or instance variables. Those are conceptually the same thing. Classes can have behaviors or instance methods, conceptually the same thing. And this is probably the big difference, though, on what classes are in JavaScript. So instances that are constructed from classes are mutable, so their properties may be added or removed at any time. And so to give you an instance of this, imagine if I created this class here called foo, and I just open and close those brackets. So it's an empty class. I can then call the constructor. I can call a constructor because if I don't define one, it has a default constructor, right? Just from object, the thing, the mother of all objects. So you naturally inherit from object. So even if we don't explicitly define a constructor, I can do this, and it's going to build me an empty foo. Now, I can go into foo and say, hey, you're going to have a key bar, and I'm going to assign you instances are mutable like objects. And then I will inspect that, and I will now see that my foo, notice it says foo here, so it does give me a class name, and it's then going to show me the key value pair. It's going to say, oh, I have a key now. Before, it did not have that. And instances are mutable like objects. So yeah, I can add and remove things after I've instantiated it. So again, that's slightly different than what you have available to in Java, where you don't have the mutability of objects. They're pretty immutable, except for the functions and that they provide to you to be able to mutate their state and whatnot. Okay, let's talk about the class keyword. The class keyword is keyword for defining a class function. So there's a couple of different ways we can define a class. We could either do class declarations or class expressions. So a class declaration and a class expression look very similar to the way that you would do this as a function. I could do keyword class in the name of the class, and then open close parentheses, which would have the class body. And so I can just quickly log that, console log that, and say, yeah, I got a class from that defined a class. And as a class expression, let's do the same thing. Let's go ahead and create a variable. I'll make it a constant, so I don't want it to change. And then I'll assign it an anonymous class. That's interesting, right? I can create a class, don't have to give it a name, just like I can have an anonymous function, give it empty body. And then if I log that, it shows, oh, look, I do add foo which is the label for my variable, I have an anonymous function called class that would have this body. And I can also have a function expression where I name my class. So I can create a variable, foo, and then assign it with a class that has the name foo. And then go ahead and console log that. And I see this looks very similar to my class declaration. It has an actual class name foo. So these are just some different ways we can create classes. And the difference here is just that one gets hoisted, the other does not. Typically, I find it advantageous to have your classes hoisted. So I typically go ahead and use class declarations. Okay, class keyword, let's talk about inner classes. So one reason why it's important to go over the concept of a class expression is because that's the only way you could define an inner class. Now, I'm not saying you're going to define inner classes very frequently, but if you do, you can only do that using class expressions. So here, an inner class is simply when you have a class defined within the scope of another class. So here I have class A, and I have its body start here and here. Inside here, I can then assign to B this class expression. And then I can instantiate on class B only when I'm in class A. And then same thing. So if I try to do class declarations, it's going to show unexpected identifier. I can't do it this way. Okay. So now let's move on to instance variables. So an instance variable is the property for an instance of a class. So I go ahead and declare my instance variables right at the top of my class body. All right, and so I can then just go ahead. I can do them a statement at a time with semicolons. I could do a comma separated list if I wanted to. I usually like to do it the same way I do in Java. So a instance variable at a time. Now, inside of here for your class variables, just like in Java, we want to declare the variables. We do not initialize them. The point of having a constructor is to initialize the state of our instance variables. But what we'll see here is if I create a class that has this instance variable of X, and then I'll just console log out the contents of the class, it's going to show me a class name of foo that has a value of key and it's undefined because no value has been defined to it yet. So one thing that we should highlight is that these instance variable declarations here are initially public. So by default, data in classes and objects is not encapsulated. Or in other words, hidden. And so they're also mutable. So technically, you may declare instance variables anywhere in the class using the this keyword. So I don't necessarily have to declare my instance variables at the top. That's a good convention, and it's a convention that we adopt in JavaScript, in Java as well. But we could just do all of our variable declarations inside the constructor and just prepend the term this in front of the variable name, and that would work as well. I think I'll give you an example of that later on, just so you can see it. So let's talk about encapsulation, though, because I said that by default, data in classes and objects is not encapsulated. And whenever I talk about encapsulated, I'm talking about being able to hide data. I'm hiding data from client code or external code, preventing it from having direct access or even visibility of it. So I can get private instance fields in JavaScript. I just have to prepend the label of my variable with a hashtag. So without a hashtag, it's public. With a hashtag, it's private. And so to prove this point, I will console log my class here and try to dereference the X, and notice I was successful. I mean, it's undefined because it's not an instance of it, right? It's an uninstantiated instance variable, but I was able to reference it from external code outside of the class definition. But if I put the hashtag there and try to dereference the hashtag, it's going to show private field hashtag X must be declared in an enclosing class. And so destructuring, so this has huge implications on destructuring. First of all, these class properties are only, these private properties are only available to classes. They are not available to objects. So that's one advantage you have with classes is this concept of encapsulation. But it does prevent destructuring. And the reason why you can't destructure private instance variables from a class instance is because that would violate a guarantee of encapsulation. If client code, if external code wanted to unpack those instance variables and have access to them, it would be able to destructure your object. So to prevent that from happening, you're not allowed to destructure. So here, I'll give you an example of destructuring our class foo for x. Notice that was successful. So I'll create a new instance of foo, and then I'll assign to it destructured x, right? I'm destructuring from it the x attribute, the x property, and that did that, no problem, no error there. If I try to do the same thing with an instance, a private field with a hashtag, I create a new instance of foo, and then I'm going to assign from that the destructured value of hashtag x. It's going to fail. It says uncalled syntax error, unexpected identifier. That is not a legal identifier inside of an object. Okay, let's talk about the constructor method. The constructor method initializes a class's instance properties, right? Just like in Java. So one of the nice things about the constructor method in JavaScript is that it's actually just called constructor, which I wish Java would have done the same thing. It would make it clearer what its responsibility is inside the class. It's responsible for constructing. So here, if I have a class of X, then I can create methods within inside of the body of my class. I can create the constructor method, and it has to be called constructor. That is a required name, just like in Java. It has to be the name of the class that the Java class is. And then the parentheses, and then the method body. And then every time I go to access an instance variable inside of my class, I have to use the keyword this. So here I will dereference this dot and then hashtag x, my private x variable, and then assign that the value of 10. So now if I try to instantiate an instance of my foo and bind that to a variable and inspect that, it will show that I have an instance of foo with the private x field set to 10. So again, this essentially looks very similar to Java. The symbols might be slightly different, but the concept's the same. Now, let's look at a constructor that takes in a parameter. I can go ahead and define parameters inside my constructor, and then I could use those parameters to set the instance variable. So here, I will create a new foo instance, passing in the value of bar. And if I inspect that, I'll see that my x property is set to bar. And then I can even have constructors that take in parameters and have default values. So here is the same parameter name, but I will give it the value of bar if none is given to it. And so now if I call the default constructor, it's just new with no new foo with no parameter, it will carry that default value of bar. And then if I did set a value in there, it would have whatever the value I set was. Okay. So then let's talk about instance methods. So an instance methods are declared in the class body with a method name, right? So instance methods may be invoked from an instance using its name and parameters. Instance methods objects may be accessed using just its name, whereas instance methods may be invoked within the class itself using this keyword. Okay, enough with the bullet point list. Let's look at some examples really quick. So on the left-hand side, I have the print method being invoked from outside the class. So I'm invoking it from an instance of the object. So here I have a class called foo. It has a constructor where it sets the property of x to 10. And here's an example where I can declare an instance variable inside the constructor by just using the this keyword and then x, right? I'm not actually declaring it in front of the constructor. I'm declaring it in the constructor. So that shows the mutability of instance variables within the class itself. And then I even have that mutability outside the class once I actually have the instance. Okay, so anyway, so I'm going to create this x property, set it to 10, and then my print method is going to console log the instance variable of x. So now if I instantiate foo into the variable foo and then say, hey, foo, invoke that print method, that instance method, then I'm doing that right off the instance itself. And so I'm going to go ahead and get that result. If I want to invoke a method from within the class, I have to use this keyword to dereference the method, to define where the scope is. So here I will go ahead and define my class foo I will give it a bar and a print method. My bar method will simply just return the string bar. Inside my print method, I'm going to invoke the bar method using this.bar, which will then return the string bar. It will bind it to the text variable, and then I'll print that text. So if I go and instantiate foo to this variable and invoke that from my instance, notice it does go ahead and print out bar. So this is just an instance of how you can invoke one instance method from another instance method. You have to use this keyword. That has to always be explicit. It's never implicitly understood, where Java does make that assumption for you. And then the bar method object. So here, let's look at this last one. Let's see, how can we access an instance method from outside the class itself? So we're going to do a I think this is the same class, right? Class foo. It has a bar method that just returns bar. It has a print method that prints things. I'm going to instantiate my foo class into an instance called foo. But now notice I'm doing foo.bar. I'm not invoking it. I am dereferencing the function object from it, and I'm binding that to X. And then, since that's a function object, I can invoke X as if it were a function, and notice it prints out bar. So I can go ahead and dereference function objects, pass them around to variables, pass them around to other functions, and do cool things like that. Okay, however, doing that with instance functions is super dangerous, and you have to know how to do it for it to work properly. And so that's what this next slide's about. So let's talk about the this keyword, because the this keyword does work differently than it does in Java. And without a little bit of explanation, it can be very confusing. So this is essentially a pointer that dereferences the object it's in context of. So whenever you use this, it always resolves to return something, because even when you start out in the global object. So you're always within the scope of an object when you're coding in JavaScript. And so this goes to the object that it's in context of, and that's what it dereferences. So this is relative based off of its scope. And so here's a special note. When you're passing a reference of an instance method, which happens quite often, honestly, to some other object or to some scope outside of that instance, then you have to bind this pointer to the function object so you don't lose its context. So what do I mean by that? I'm going to show you the wrong way, then I'm going to show you the right way. So let's look at this wrong way. I'm creating a class foo. It has a constructor that's going to set the X instance variable to 10. It has a print where it's going to print out the value of its instance variable of X. And I'm going to say, oh, I want to create a new instance of foo. I'm going to bind that to foo. Then I'm going to take the function object from foo. So foo.print. I'm going to dereference the function or method, the method object, and I'm going to bind that to this variable called print. And then I'm going to try to invoke that. Now it worked up here, and it worked up here because I didn't have a reference of this, right? I was just returning bar. The reason why all of a sudden I get this error, uncalled type error, cannot read property X of undefined, is because undefined is this. This, which is now the global object, which is where this print method is at now. When it goes to invoke this method, when it goes to use this, it's not inside the instance anymore. It's in the global object, and the global object doesn't have a property called X. And so that's why I can't read a property of X there. So even though this is a valid function object, since it relies on this pointer, and that changes in scope, depending on where you're invoking your function, it can lead to failure. So suppose I wanted to access this function object, but keep the context of what this means. Where is this thing at? So to keep the context, we're going to do the same thing here. But notice on this line, the only difference is from my foo.print, deriving the function object, I can call on a function object a bind method. So all function objects have a bind object, and you can pass it the object it's supposed to associate as this pointer. So here I have foo, that's my instance, and then I'm going to pass print, which is my
function object, and then I'm going to bind to my function object the reference of foo as my this pointer. So now if I go ahead and invoke that print, it prints the value of 10 the way I would expect, because it's looking towards that instance now and not the global object. Okay, so that's just a little nuanced thing. So more things you should kind of be aware of with the this keyword is that in a method, this refers to the owner object. So inside of the classes, it refers to the objects it's in. You can actually use this inside of literal object notation as well. So this can be used in any object, and it refers to the object it was declared within. Alone, so if you just use this, and I think I've showed this before, if I just do this right inside the interpreter, it points to the global object. So it always, in a function, this refers to a global object as well. So alone, so in imperative programming, this would refer to your global object. Inside of a function, so procedural function programming, this refers to the global object. Inside of a object or inside of a class, it refers to the owner object or the instance. And in an event, it's going to, this refers to the element that received the event. So this is going to be probably where we get our most nuance with using this, and where we're going to want to bind it later on when we get to event handling and callback functions. And so we'll expect that, but I'm kind of laying the groundwork for why this is necessary to know. Okay, let's talk about the static keyword. So just like we have instance methods and instance variables in Java, and then we can have static methods and static variables, same is with JavaScript. So static keyword is used to model property or method of the class itself, not just an instance of that class. The static values are the same for all instances of the class, right? It's a definition for the class. However, this is where we distinguish from Java. To dereference static properties from the we have to use a class name. We can't use an instance name from it. So here, suppose I have this class foo, and I have this static property x, and I'll assign it to bar. I could assign it outside of a constructor because it's not an instance variable. It's a property of the class. And then from the class itself, from the class name foo, I don't have to instantiate it to access it. From the class name foo, I can then access that value of x, and there I go, I dereference bar. Now, if I did instantiate an instance of my foo and then try to, from the instance of foo, access x, it's actually looking for an instance variable and not a class variable, so it's going to show that it's undefined. So do keep in mind that if you do have static attributes, you have to dereference them from class scope. You can't do it from instance scope. Okay, we've talked a lot about objects. We've talked a lot about classes. Let's talk about class-based inheritance. So, inheritance is pretty much just the keywords of extend, super. We'll look at method overriding and just a little bit about polymorphism. Polymorphism is a little easier in JavaScript simply because everything's loosely typed. So we're not as constrained by the type as we would be in Java. So in JavaScript, class inheritance is the same thing you would expect it to be in Java. Inheritance allows for a class to become a member of some other class, inheriting all of its properties, all of its behaviors, and even its type, while also allowing it to define its own properties, behavior, and its own subtype. So one note is that subclasses do not have access to superclasses' private fields, right? That's the same thing in Java. If you declare something as private, you lose visibility from it, not only from external code, but from any inheriting subclasses. So if you do create a superclass that a subclass will inherit and it has private fields that it needs access to, make sure you create getter methods for it. Okay, let's talk about the extends keyword. The extends keyword is used to in class declarations or class expressions to create a class that is in a child of another class. So let's take a look at this. I have class A, and my class A has a print method that will just print out console log. It'll print out A. Then I'm going to create a class B that extends class A. And so now if I instantiate B and save that to a variable that we'll call B, we'll see that this is B, right? I can unpack that. I can say, oh, I have an instance of B, class B, but its prototype is A. So the thing it's a subclass of is A. And so if I say, hey, B, invoke your print method, well, I didn't define a print method inside of class B, but since I extended A from B, then I inherit that print method, and I could do b.print and go ahead and get A to print out. So again, this works exactly as inheritance does in Java. Let's look at the super keyword. Again, exactly as you'd expect it would based off of your Java programming experience. The super keyword is used to access and call functions on an object's parent, or to invoke the parent class's constructor if it requires parameters. So let's look at this, and I create some little descriptions here on the side here. So I'm going to create a class A. It's going to have an instance, private instance field here, foo. And the constructor, I will instantiate foo based off of a parameter that gets passed in. So when I define class B here and extend A from B, so class B extends A, and define B's constructor, the first line of code I should do here is to invoke the parent class's constructor using the super keyword and passing in as a parameter the data that class A needs, so I can appropriately instantiate an instance of B. And so now when I invoke my constructor on B, I can see it goes ahead and creates a type B, and it has a field that inherited from A called foo, and it's set to B. So, yep, we can see how super works in that regard, to be able to invoke a parent constructor or a parent method or access some kind of parent data that's at least publicly available. So with that, so now that we know how extends and super works, let's talk about how we might use that for method overriding. So recall that method overriding just means it allows a subclass to redefine the behavior of a method from one of its parent classes. So here you can have a class that can access both the parent class's method and its own method, depending on whether it's using the super keyword or the this keyword. So in this instance, we have class A that will go ahead and it will have a print statement that just goes ahead and console logs A. Then we're going to create a class B that's going to extend class A. So it's going to be a subclass to A, and it's going to create its own print method. So now we're method overriding. We're overriding the print method that was inside of class A with a print method inside of class B. So this will console log B. I'm going to create another method, though, just to prove that inside of class B, I can access both the method that's defined in my parent class and the method defined in this class by using the super keyword and the this keyword. So I could do super.print, that'll print out console.log A. Then I'll do this.print to print out console.log.b. I mean, just print out B. So if I instantiate the constructor on my class B and save that to a variable, and then on that instance, I invoke the instance method, print all, I see it does invoke the super method A, and then its method, its overridden method B. So sometimes it's the case where you have to still invoke a parent class's method, but you want to change a little of the behavior before you invoke it. We do this in the last portion of the platform lab where you define animations, where inside the draw animation, you want to update the hero, the player's animation before telling the object to draw. So you will get to see this in practice. Okay, and the last thing I want to talk about in terms of class inheritance is polymorphic behavior. So when using inheritance for polymorphic behavior, sometimes you opt to need to check an instance, to check to see if an instance is a member of a subclass in order to invoke a very specific behavior. So you have access to an instance of operator for that reason. So I know in JavaScript basics, we've talked about how there was this instance of operator. That's a big use case for it, where you can check whether an instance is a member of a particular class. So if I had a class A, which is empty, a class B that extends A, which is also empty, I instantiate instance of class A, instantiate an instance of class B. I could say, is A an instance of A? That's true. Is B an instance of B? That's true. Is B an instance of A? Yeah, that's also true. And then I could, if it is true, I can invoke a very specific thing, right? Like if I had monster classes, but one was a dragon and breathed fire, I could make sure, is this monster a dragon? And if it is, then tell it to breathe fire. So I could do very dangerous things, right, by checking to make sure it has an instance of a subclass first. Okay, so this concept of class inheritance is relatively new. Before class inheritance was a thing, you have what was called prototypical inheritance. I don't want to get into the details of it, but I'll just give a quick example. So in JavaScript, Objects may inherit properties and methods from a prototype property. So before we had the class keyword, inside of an object, you would define a prototype key and then give it whatever the value of like your class was that you wanted it to be called, and then whatever attributes were defined in that particular object would then get built into new objects. So object has this. So imagine if I had this foo here, and so foo has a prototype property that is foo, and it has a name called hello. And then from the object class, we're going to invoke its create method and pass in foo, and we'll bind to a bar variable. Notice it at first glance, it looks like bar is empty, right? Because that's the same thing that happens when you inherit and call the instantiated property, is that the local view of bar doesn't have anything yet, but it inherited the name, the property name from foo. So if I go ahead and say, hey, object, can you tell me what the prototype of bar is? It's like, oh, bar has the prototype of foo. It has the name of hello. I'm like, it actually has that property. I don't see it in here. Let me try to access it, bar.name. Yep, it certainly has that. So that's just to give you a flavor of how we're not going to use this at all in this class, but if you were to look at any older code, this is how you would be reading what's happening there. But we're going to use all the newer syntax of JavaScript and use appropriate class branded inheritance. So let me quickly go over our spread operator and destructuring. Remember, destructuring assignments allow us to unpack properties from an object into distinct variables. We use the spread operator when we have multiple elements from an object that need to be dereferenced and kind of packed together and included. So we kind of looked at this before. If I wanted to do object destructuring, so if I had a property of A and B and I wanted them to just be their own values of A and B, I nest my destructuring, my curly braces right in there. So I can, in my assignment, when I do my my declaration of variables, I do it between curly braces. And then if I want to use the spread operator to capture a subsection or grab the rest of the elements from a destructuring, I could use the ... So here, if I take A, comma B, comma ... rest, I can capture A as one variable, B as one variable, and then C is a it's a new object built off of the remaining properties. So remember, so keep in mind, that's a great way to remove elements or properties from an object. Now, on the right-hand side of destructuring, I could do this. I can have an object A that has these properties. I can merge. I can use destructuring to merge two objects or to merge an object with a new property if I want into a new object. So here, B is going to be a new object that has the same properties as A and this new property C. See, so if I inspect B, I have A, B, and C. With my spread operator and destructuring, I can go ahead and merge. I can destructure and spread out two objects into a massive object that has an A, B, C, and D. I could dereference the A and the C, bind them to their own variables. So what if my intent was to mix and match two objects to get a combination of their properties? That's what Z is. I omit A and C, so the results of Z using the spread operator will give me an object that includes just B and D. So again, there's plenty of ways that you can mix and match objects using the spread operator and destructuring object. We're going to see that a lot when we get into using frameworks and in terms of importing code from modules and other sources of JavaScript objects. Okay, so I want to talk about the last part of today's lecture. What are some of the static methods that are defined in class objects? There are four main categories I want to go over. There are object generator methods, there are object transform methods, there are object encapsulation methods, and there are metadata objects, which are probably the least important, which is why I put them at the very last of this lecture. So there are two ways that we can use class object static methods to generate new objects themselves. I can either use the create method or the assign method. So with the create method, it creates a new object with a specified prototype object and properties. As we saw just earlier, this was traditionally used to implement the prototypical version of inheritance. We will not be using this, so I'm not going to go into a lot of detail of what's going on here. With object.assign, we will use this method on those instances where you want to go ahead and make a copy. Or if you want to assign a set of attributes from one object to another. So essentially, assign allows you to copy the values of one object's property into some source object. So look at the source code here. I have a target object that has A and B. I have a source object that's called B and C. I will use the object static method assign to pass in the target and the source. So the things from the source will then be written into the target object. So I will then go ahead and log target. I will then log returned. And I want you to illustrate, I want to illustrate that object assign actually mutates target, but it also produces, it returns out a new object. So notice I can do this assignment on this as well. So if so the reason why that's important is I can pass in a empty object literal here that's not referenced to some named object that's stored in memory, and it still will return out a brand new object that's different than the target object. So these are actually two different entities, the target and the return target. Okay, let's look at our transforms. Just like what we saw in arrays, one of the powerful things about like these container classes is being able to convert them into other container classes. So we can easily transform objects or essentially dictionaries into arrays. So we could do that with the keys method, which works differently. So in arrays, keys and values and entries, all of those methods were iterator methods, right? They returned iterators. But in objects, they're going to return arrays that contain the keys. So here, if I have an object and it has two keys, X and Y, and I say, hey, object, I'm invoking your static method keys, and I'm passing you my my object instance, it's going to return the array of those keys. And so very similar, I have object.values, where if I create an object and I pass it to object.values, it's going to return the values of my properties. And if I need both, then I could do object.entries and pass it my object. So here, I create an object, X and Y, 0, 1. I ask for the entries. It's going to give me an array of arrays where the first index is the key, the second value is the second index is the value. So key value pair. So again, these work very similar to the way that the data structure, as they did in data structures. They just are returning arrays. So this is an easy way for us to convert all of our objects into arrays. If we need to, for some reason, use those very powerful array processing methods on them to get that functional programming, to be able to cascade or chain calls one into the other. And so there is the ability for us to take an array and transform it back into an object. And we saw this in the data structures, but I want to reiterate it here since it's since this is also part of the same topic. So we can have the from entries on object where we pass it in, no, not an array. We pass it in an array. Or not an object, but we pass it in an array. So here, if we have a nested array, where it's an array that contains key value pairs in the form of an array, then it will then remap that into an object with keys and values. So here I have the key X, value 0, key Y, value 1. Okay, so the next thing I want to talk about is the encapsulation methods. So we talked about the importance of encapsulation in private fields, where encapsulation allows us to prevent client code from essentially mutating the state of an object. We're allowed the object to kind of control its own state. We do get these static methods that allows us to give us this concept of encapsulation on objects themselves. So we have something that's called prevent extension, object.prevent extension, which prevents new properties from being added to an object. So let's see what this looks like. I'm going to create this object that has a property X. Then I'm going to say, hey, object, prevent extensions on that object. So I have object.x, and I'm going to try to mutate it to 1. I can do that. But on object.y, I'm going to try to set a new, I'm going to try to extend it with a new property. And notice when I console log it, it does not allow me to do that. So if you want to lock an object down so it can't be mutable with new objects, you can do that. Now, I will say you can still delete the properties from them. This doesn't prevent you from deleting the properties. It just prevents you from being able to mutate and add on new ones. And then we can even check if an object has been prevented extensions. So we can say is extensible. And we'll see here we have our object we're going to call prevent. Oh, I didn't include my code for its extent. That just returns a Boolean value on whether this has been applied or not. I just wanted to. This was a proof that you can actually delete a data property from an object, even if you prevent it from extending. You can still remove them. And then here, this returns a Boolean value, so it would show me it's false. You can't extend this. Is this extensible? No. Okay, then there's this concept of seal, which is even more strict. It prevents other objects from deleting properties of an object. And by default to deleting, that also means you can't add either. So it's like one step higher in encapsulation than the previous. So if I have the same object and I tell it to seal it, and I'm going to try to mutate the state and try to add a new property, it does not let me add. But now if I create the same object, I seal it, and I'm like, okay, delete that element X, that property X off of it, and then console log, I still have that X. I can't do that. And then if I want to check to see if it's been sealed, I can do object.isSealed, pass it obj, it'll say true. If I pass it an empty object, it'll say false. And then even tighter than that, I can freeze an object. So I can call object.freeze and freeze an object such that other code cannot delete or even change its properties. So that object is frozen in that state. And so here, let's look at the same kind of object. It's just X is assigned 0. I'm going to freeze it. I'm going to try to reassign the value of 1. I'm going to try to add or extend a new property on there. I'm going to log. I see that I did not mutate the state of X. I did not add Y. And then I also have is frozen. That just is a Boolean return on object is frozen, true or false, to be able to check. And then like the last thing I just want to cover in today's lecture is going to be the static methods that give us some metadata on our objects. So we saw how we could define or add properties into objects using the dot notation or the bracket notation, or even like the assign notation or the spread operator notation. But objects actually has a method called define properties or define property that allows you to add named properties. But it also allows you to provide descriptions for those properties. So just to give you an example, I have this empty object. I'm going to define these properties. Let me do this bottom one first. So I have this empty object. I'm going to define one property. So I'm going to pass it in the object, and then the name of the property, and then the value I want that property to have. Then when I console log this out, I see that I now have an object that has the property foo, and it has the value of bar. And I could actually do that for a collection. So I can pass it an array of properties. And so in object define properties, I can pass it the object that I want it to define these properties on. Now, I know what you're saying. Why this really complicated way, where there's other attributes, not just value. So in the properties that I pass it, value is just one of the keys that I can define. Other things that all properties have are also whether the property is writable, whether the property is enumerable, or if the property is configurable. So by default, these are all set for you, but you can actually inspect what the property descriptors are. So again, suppose I had that object that had foo, bar, and spam eggs. And then I use the object static method, get own property descriptor from object on the property foo. It shows me the value of foo is bar, that it's false that it's writable, that it's false that it's enumerable, and that's false that it's configurable. Or I can get, I could just pass the object itself and get all the property descriptors. So the important thing, though, is that these writable, enumerable, and configurable aren't typically going to be useful to know unless you're using JavaScript in like a strict mode. If it's in a strict mode, you can start making things not writable, or enumerable is actually useful, because if you define something as not enumerable, whenever you use like the keys or vowels method on it, it won't return that. And I just want to give an instance of what that might look like. So on this method, get own property names, if I were to pass an array instance there, like the array of A and B, it will actually show me that it has the value of 0, the value of 1, but then also this value of length, right? These are the keys in an array. 0, 1, and length it's not enumerable. So if I was to do the same thing with the keys it would just show me the just 0 and 1. So keys does not give me the enumerable properties, whereas get own property names does. And so this is just an illustration that some of these decisions that happen in these methods are made off of these hidden values, these hidden descriptors inside of a property. So for any reason you're getting some behavior that you might be unaware of, you can always inspect the metadata on your objects, even the prototype of. So again, like we talked about with prototypical inheritance, we could do get prototype of and pass it an object. And so if I were to do that, it would show that the prototype of that object comes from whatever the superclass is. And that's it. We covered the entirety of object-oriented programming in JavaScript in today's lecture. So between the lab and this PowerPoint slide, which I'll provide as a resource to you, along with this lecture video, I think we should be, for the most part, good to go with JavaScript as a general purpose programming language, because we covered all the basics. We talked about creating functions. We talked about all the applied data structure techniques. We talked a little bit about functional programming with it. And then we talked about everything that relates to objects and classes. So before we end today's lecture, is there any questions about what I discussed today? Again, a lot of it correlates with Java, or there's at least a something that's analogous to Java. But I will, oh shoot, I'm just realizing I've been in here. I don't know if I've been getting questions. No, okay. So, or is this apparently making a lot of sense? Are you feeling pretty confident and comfortable with JavaScript as a programming language based off of your 3 semesters of Java? Excellent. Has anyone started working on the lab? Have you noticed that these concepts that I've talked about for these last 4 lectures or so have carried over inside the lab content? Excellent. And again, if there's any, I think after having this lecture too, being able to read the content in the lab will make a lot more sense. But I think between doing that and reading this, working in frameworks that will use some of the syntax, you'll be able to parse and understand what's happening very easily. So that you won't be learning JavaScript while we're learning Express or React. We'll be learning what the framework does, because we've had a pretty, not a crash course, I think a pretty decent amount of material invested in learning all the syntax of JavaScript. But trying to do it in a way that yields your Java knowledge. Okay, well, with that said, I will leave you all to go today. I will see everyone next week. Have a great weekend. I will stop the recording.